So, what kind of a system is this? There's something special about this one. How do I start these problems? How do I start every problem in this chapter? Energy. But this problem has what other thing? Yeah, work done by friction. So this is a non-conservative system. So this is a democratic, whatever, yeah, democratic system. This is a liberal system. And remember that liberal systems bleed energy, just like liberal governments bleed money. Just kidding. Come on, just kidding. I mean, just as a, clearly the Bush administration bled a ton of money in the whole stupid Iraq war thing. So both sides, politicians like to bleed money. So, sorry, what? Is that a good joke? Yeah, it's recording. That's why I'm saying both sides, because I don't need some you're trying to convert my team. So there is good to both sides. All right. Yeah. So we say MEI equals MEF plus work done by friction. What kind of energy do we have in the beginning? A skater gliding across the ice, right? So it's going to be kinetic. And then what kind of energy do we have at the end? Also kinetic. Kinetic, fine. Yeah. And then we have the work done by friction, which is going to be the force of friction times x. You know what? I should get rid of that, otherwise somebody's going to think that's a dot product. The force of friction times x. Okay, so here we get 1/2 m. Now, actually, let's take a look at that. So this is sliding on ice, but there's a little bit of friction. Do the force diagram on your paper now. Go. Okay, obviously first we draw in gravity. Second we draw in normal force. Third we draw in friction. There you go, there's my force diagram. And what is my sum of the force statements in the x direction? Excuse me? Oh, yeah, we don't care about that. Because we're only concerned, they ask us to find mu. So there must be friction, right? We're just concerned with the rough patch. So sum of the forces equals ma. So we have F sub F, or negative F sub F, equals ma. If you want to get a negative acceleration, because your velocity is in this direction. So you're accelerating in that direction. And then the sum of the forces in the y are 0. So you get F sub n is equal to F sub g. You substitute in F sub F. You get negative mu mg equals ma. Oh, that's annoying. Should we do it that way? Oh, just kidding. Sorry. What was I doing? I was using the wrong stuff to solve this problem. Whoops. Okay, well, anyways. That actually all works, and we could actually find mu that way. But as I went on this long diatribe earlier, what we have to do is, in this right here, F sub F is mu. I'll show you what I wanted to do. What I was trying to communicate here, but I guess I can just use the equation. F sub F is equal to mu F sub n, right? And then based on our force diagram, F sub n is F sub g. So F sub F is equal to mu F sub g times x. And then that gives me 1/2 mvi squared equals 1/2 mv final squared plus mu mgx. So sorry, I didn't have to do this. I apologize for that. But do you see how this works? And now we can cancel out the mass. And if we can cancel out the mass, then we get mu is equal to vi squared over 2 minus vf squared over 2 all over gx. So if you multiplied everything by 2, then you can make it a little easier to do. So you get vi squared minus vf squared all over 2gx. Okay, and so vi squared is 100, minus 81 is 9, and then 9 divided by... Sorry, what? I multiplied everything by 2 over 2. I multiplied this by 2 over 2. You see it? Okay, that way I can cancel those and get 2gx in the bottom. So I get around 1/9, which is like, I don't know, 0.1, is it, what is it? 0.2, okay. 0.2. Check and see if you get that. 0.2, 2, 4, 8, so it's 8. 100 minus 9. 100 minus 9. 81. Oh, yeah, I do it the other way around. 81, and then 81 divided by 480. X is 4. So did everybody get 0.2? Cool. Excellent.